All right, guys. So moving on today with the second lesson of Unit 6, we're going to be talking about measures of spread. But very quickly, before we go on to the new material, just a quick recap with the warm-up of what we did in 6.1. So 6.1 covered mean, median, and mode, or in other words, measures of central tendency. Okay, so in the warm-up here, we are asked to come up with a set of 5 pieces of data that would have a mean of 75 and a median of 79. Okay, so I'm not going to spend too much time on this. You can pause the video now and try to come up with your answer. Okay, and moving on to the answer. And some of you may have thought this when you saw the question, but yes, there are a multiple number of possibilities to fulfill the criteria the question has set out for us. So as long as you have a mean of 75, so basically meaning all of your 5 pieces of data give you an average of 75. So to get an average of 75 with 5 pieces of data, I would basically just do 75 times 5, which is 350. And any 5 numbers that add, when you add them together, add to 350, will give you a mean of 75. The other thing to keep in mind is the second part where it says median. And you need to make sure of your 5 pieces of data that one of them is obviously 79, and the other 4, 2 of them have to be above 79 and 2 of them below 79. Okay, so you can see the answer here. One of the possible answers there, that works. So quickly, if the class median was 79 and you had an 80, does that mean you're doing well? Well, not necessarily. What if you had a 79 and everyone else in the top half of the class was around 100? Right? So that means you wouldn't be doing as well as you may have thought. Okay, so there's limitations to median is what we're getting at. Okay, so measures of central tendency are useful tools. So something like median is useful, but doesn't always tell the full story. So we're going to move on to today's lesson, which will help kind of tell more of the story. And that lesson, like I said, is on measures of spread. Okay, so measures of spread help to show how closely data is centered around its center. Okay, so exactly how little or how far is the data spread out from that central, whether it's the mean or the median or whatever figure you're talking about. Okay, so here in the example, you scored a B, it says. In the test, 12% of the class got a D, 50% got a C, 30% got a B, and 8% got an A. You got a B, right? So we add up the 12% that got a D and the 50% that got a C and half of the 30% that got a B. Okay, so by adding all of those up, it tells us all of, or where you stand in terms of the number of, well, the percentage of people you did better than. Okay, so the reason we use 15% for getting a B is we're not going to assume that we got a really high B or a really low B just to try to estimate or get our best guess here. We're going to use the midpoint or assume we were at the midpoint in that B range. Okay, so adding all that together, we get 77, like I said. So that tells me that you did as well or better than 77% of the class. Okay, so that is a way to see where you are relative to everybody else in the class as opposed to just comparing yourself to a median or a mean average. Okay, moving along. So we just discussed, we were, sorry, going back for a quick second here. We just discussed that we did as well or better than 77% of the class. In other words, the percentile rank, which is what we see on the next slide, is 77. And what do we mean by percentile rank? The percent of all of the data that are less than or equal to a given data point. So if we're at 77, like we were in the previous question, that means 77% of all the data are less than or equal to the mark of B that we got over here in this question. Okay, so 77% are less than or equal to, which would then mean that 23% of the class did better than you. Okay, So that's percentile rank. How do we figure out percentile ranks given a bunch of data? Well, there's a formula. Okay, so here we want to know, in the example, we're given the following marks on a quiz. Find the 80th percentile. So what that is saying is find the mark that represents the 80th percentile. Okay, so to do that, we use this formula here, where it says R equals P over 100 times N plus 1. Okay, so R is the percentile rank, P is the percentile, okay, that you're looking for. In this case, it's going to be 80. And N is the size of the population. In this case, we have 25 students, so that'll be the size of the population. So basically, to figure out the 80th percentile, we're just going to plug in all the numbers that we know into the formula and figure it out. So to solve for the rank, we're going to sub in 80 for the p-value, which is the percentile, which we've done there, over 100. And as I stated earlier, the n value is 25 because we have 25 students in the class, and then the plus 1 from the formula. So solving for that, that gives us 20.8. So what that is that 20.8 tells us the rank of the 80th percentile. That does not mean that the 80th percentile is a mark of 20.8. However, it means that we will find the mark of the 80th percentile if we look at the term in the 20.8 8th rank. Okay. In other words, there's no 20.8th rank. We will look at then the 20th and the 21st data point, right? Because 20.8 falls between 20 and 21, and find the midpoint of those two data points, and that will tell us what the 80th percentile mark is. So we start at the left, count up to 20 and 21, and we get to the 20th. Rank is 34. The 21st ranked mark is 36. So the 80th percentile then is going to be the midpoint of those two. So the midpoint of those two, 34 plus 36 divided by 2, gives me 35. So to answer our question then, what mark represents the 80th percentile? The mark of 35 on this quiz would represent the 80th percentile. Okay, so 20.8 tells us where to look in our data set. So here we count from the left up to 20 and 21, find those two numbers, 34 and 36, divide the sum of those two numbers by 2 to get our final answer. Okay, so that is how you could figure out the mark in any sort of percentile you're given. In this case, we're given the 80th percentile, but you could figure out the mark of any percentile. Just use the formula and plug in your numbers. Okay. Another way you could be asked a question is, in this next example, the following are the marks for 25 students on a quiz out of 40. Okay. What percentile is a mark of 25? So in the question below, we were asked what mark is the 80th percentile. Now we're given the mark and we want to figure out the percentile. So for this, we also have a formula, which you can see right here in the green box. And that formula, P is the percentile. L represents the number of data lower than the given data point. In this case, so all the data points, the number of data points we'd have below 25. E represents the number of data points equal to 25. And then N is still the number of data points that you have. Okay, so to figure out what percentile is a mark of 25, use this formula here and plug in your numbers. Okay, so L says the number of data points lower than the given data point. So if we count here, lower than 25, we have 1, 2, 3, 4, 5, 6, 7. So we plug in 7 plus 0.5. E is number of data points equal to the data point. So how many data points do we have equal to 25? We can see right here we have 3 25s. So we plug in 3. And then N is the number of data points, which is 25. So solving for that, it tells us that we are in the 34th percentile. So a mark of 25 represents the 34th percentile. Okay, so there are the two ways you could be asked a question. You either given the mark, figure out the percentile, or given the percentile, figure out the mark. Okay. Moving on to quartiles. Okay, so when we talk about quartiles, it's just like it sounds. Divide a set of ordered data into 4 groups, right? You're dividing it into quarters with equal numbers of values in each of those 4 groups or quartiles. Okay, so Your first quartile here is your lowest data point up to Q1, which is your 25th percentile. And then your second quartile would be your 25th to your 50th percentile, then 50th to 75th, and then 75th to 100th would be Q3 to your highest data point. Okay. Another term that comes up when we are talking about quartiles is interquartile range, and that is basically Q3. So whatever this value is here, subtract Q1, whatever this value is here. So what that interquartile range tells us is the range of the middle half of the data. So from the range of Q3 to Q1 or Q1 to Q3. Okay. Outliers we've talked about before. A piece of data that is notably far away from data clusters. In terms of figuring out exactly whether we have an outlier or not, there's actually a small little formula here that we can use to figure out or show whether we have an outlier or not. So to figure out if we have an outlier on the lower end of our data, we take the Q1 value and we subtract 1.5 times the interquartile range. So whatever this interquartile range is here, you multiply it by 1.5. Whatever that product is, subtract that from the Q1 value, which is there, which is your 25th percentile. So whatever Q1 minus 1.5 times the interquartile range is, that is the lower barrier for outliers. And then conversely, on the higher end of the spectrum, you take Q3 plus 1.5 times the interquartile range, and that is the high barrier. So any points falling below the low barrier or above the high barrier would be considered outliers. So to prove that or to show that, you would do this calculation here, and then you would check your data points to see if you had any numbers lower than the low barrier or any numbers higher than the high barrier. Okay. And a way to show graphically, show this information graphically is we use what's called a box and whisker plot. You can go to your textbook. It says see page 272 for graphing instructions, but it's the pages in and around 272 as well, which will show you how to graph box and whisker plots. Basically, you have a number line, you draw a rectangle. Okay, so the lower end of your rectangle is a vertical line at Q1. The higher end of your rectangle is a vertical line at Q3. Okay, so you draw your vertical lines at Q1, Q3, make that into a rectangle, and then your Q2, which is your median, you draw that within your rectangle wherever it fits. Okay. So that's the box part of your box and whisker plot. The whiskers are the lines to either side of the rectangle. So Q1 is there. You would draw a point representing your lowest data point or lowest value, and then draw a vertical line connecting the left part of your rectangle to that point. And then you do the same thing on the higher end. You would draw or put your point of the highest value that you have, and then draw a horizontal line connecting that highest value to the right part of your rectangle. Okay, so there is your box and whisker plot. Here we're just showing a box and whisker plot, and you're showing outliers out over here. So really, you can show your outliers however you want. You can put your highest data point here, and then you could even show me, let's say your interquartile range was there. Not interquartile range. Let's say the high barrier to show outliers was right here. I'm fine with you basically, maybe doing it in another color or drawing a line here with an arrow saying the high barrier, and that would tell me any points to the right of that would be outliers. Okay, so draw your rectangle, and Q1 is the left-hand side of your rectangle, Q2 is the right-hand side of your rectangle. Once you have your rectangle, your median goes somewhere in that rectangle. So depending on whatever the value of the median is, you would draw your vertical line within that rectangle to represent the median. Okay. Then your lowest data point over here, highest data point over here on the right. Okay. So we have an example here, and what I'm going to do with this example is stop this video here because I have basically a 15-minute time limit on the video, and we're kind of right at the time limit. So obviously don't want to rush through this example. So I'll put a part 2 to this lesson in which I will be doing this example or explaining this example to you. Okay, so move on to part 2 and we'll go over this example together.